Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to discuss another important topic. The topic is line integral. So we'll discuss the idea of line integral today. Suppose this is our coordinate system x, y and z, and there's a curve in this space from point A to B, right? Now a particle moves from point A to point B along this path. Along this path, force acts on the particle, and that force varies along the curve. Now, at one location, we show dr as infinite small displacement, and at this location of the path, let force be represented by this vector, right? What we do, we are interested in calculating the work done by this force F acting on the particle which moves from point A to point B along the path shown. So what we do, we divide this curve into infinite small displacements dr and find the work done by the force F for each displacement. If dw is the work done by the force F on the particle during infinitesimal displacement dr, then dw by definition of the work is equal to F dot dr, right? So dw is the work done by the force F on the particle during infinite small displacement dr, and by definition this dw is F dot dr. Now we are interested in finding the total work done by force F as the particle moves from point A to point B. So what we do, if W is the total work done by force F, this total work is simply the integral dw, which is integral dw from point A to point B, which is simply integral F dot dr from point A to point B, right? So W is the integral F dot dr from point A to point B. So such an integral is called a line integral. Let me write it with some another color. such an integral is called a line integral. So a line integral means an integral along a curve or line. Line integral means an integral along curve or line, right? So when we calculate line integral, we have some curve along which we evaluate that line integral, and we have some vector. In this case, we have vector f. Then we divide that curve into infinite small displacements and find the dot product of force. In this case, force, it can be some general vector field. We find the dot product of the concerned vector with the infinite small displacement. Then we add these dot products over the whole curve from initial position, in this case A, to final position B. This is the idea of line integral, right? There is another idea which we want to discuss here, conservative and non-conservative fields. Now, a force field, let me write it, a force field for which this work, which we wrote as a line integral, integral f dot dr, depends upon the path as well as the endpoints, is called non-conservative, right? This is the definition. That means if we have a force field F, right, in which case this integral f dot dr depends upon the path taken in solving this integral as well as the endpoints of the path, then the force field F is called non-conservative. Physically, that means the energy has been dissipated. For example, friction is a non-conservative force field, right? There are, however, conservative fields for which the integral f dot dr is the same between two given points. Regardless of what path we calculate calculate it along. This is for conservative fields, right? So in conservative force field, this integral f dot dr, this line integral, is the same between two given points, regardless of what path we calculate it along. So it is, this integral for conservative fields is path independent. It is fixed for two given points. For example, gravitational field is a conservative field, right? And there is another important point, how we check some force field is conservative or non-conservative. Now you need to remember, ordinarily curl F equal to 0 is a necessary and sufficient condition for integral f dot dr to be independent of the path, that is, curl f equal to 0 for conservative fields and curl f is not equal to 0 for non-conservative fields, right? So if you have to check some force field is conservative or non-conservative, what you do, you calculate the curl of that field. If curl F is 0, then the field is conservative. And if curl F is non-zero, the field F is non-conservative, right? And the point to note, if F is gradient of some scalar W, then curl F is equal to 0. Conversely, if curl F is equal to 0, then we can find, let me write here, conversely, if curl F is equal to 0, then we can find a function, scalar function, W function of x, y, z, for which f is the gradient of that scalar W. Understand it? I am saying if f is gradient of some scalar W, then curl f is 0. Conversely, it is also true, if curl f is 0, then we can find a scalar function W x, y, z, for which f is gradient of W, right? Now in mechanics, in mechanics, if f is gradient of some scalar w, that is if f is conservative, then w is the work done by f, right? Also, f is minus times the gradient of some other scalar function phi. The function phi is called the potential energy, or the scalar potential of the force F, right? To understand it, I'm saying if curl F is 0, then the force field F is conservative, and then it is also true that that force field is gradient of some scalar, and that scalar in mechanics W is the work done by force F, and then there exists some other scalar phi, for which you can write F equal to minus times gradient of phi. The function phi in mechanics is called potential energy or scalar potential of the force field F. Now, more generally, for any vector v, if curl v is 0, there is a function phi called the scalar potential of v, such that v is minus gradient of phi. I repeat, for any vector v, if curl v is 0, that is v is conservative field, then there exists a function phi called scalar potential of v, such that v is minus gradient of phi, right? This was about the idea of line integral, then conservative and non-conservative field, and the conditions for testing whether some field is conservative or non-conservative. Now we will do an example that will be helpful to understand the idea. So the example goes like this. Let me use another color. Example says, show that F equal 2xy minus z cube I cap plus x square j cap minus 3x z square plus 1 k cap is conservative, and find a scalar potential phi such that f is equal to minus gradient of phi. This is our question. Now we will discuss solution. Before going to solution, let me check the problem. Show that f equal to 2xy minus z cube I cap plus x square j cap minus 3x z square plus 1 k cap is conservative, and find a scalar potential phi such that f is minus gradient of phi. So we are given a force field. We have to check first that, or we have to show that it is conservative, and then we have to find a scalar potential corresponding to this conservative force field. So what we do to test or to show that this force field is conservative, we will find its curl. So we find curl of f. How we do that? We evaluate this determinant. Let me use another color. Let me use this one. So our determinant is I cap, j cap, k cap, then dou by dou x, dou by dou y, dou by dou z. Then we write the components of the force field F. Here we write x component, which is 2xy minus z cube, 2xy minus z cube. Here we write x square. Here we write minus 3x z square plus 1 minus 3x z square plus 1. When you solve it, it turns out to be equal to 0. Check it at home. Check it at home. So it turns out to be 0, which means that f is conservative. So f is conservative. So if f is conservative, there exists now a scalar w and scalar phi. So we are asked to find phi. We will find w, work done by this force. So work done by the force is line integral from some position A to B, f dot dr, right? Which is simply A to B 2xy minus z cube dx plus x square dy minus 3x z square plus 1 dz. because infinitesimal displacement dr is simply dxi cap plus dy j cap plus dz k cap. Now f dot dr is just x component of f times x component of dr. X component of f is 2xy minus zq dx plus x component of f, y component of f is x square, and y component of dr is dy. Same goes for z component. Z component of f is minus 3x z square plus 1. Then dz is the z component of dr. Now we have to evaluate this integral in order to get w. When we get w, we can find the scalar potential phi, right? Because phi is minus times w. Now we have to specify a path to evaluate this integral. But we have an advantage. Advantage is f is conservative, and we know for conservative field, this work depends only on endpoints A and B. It is independent of the path. So we can choose any path for our convenience to calculate W. So W is independent of the path, right? Because F is conservative, W is independent of the path. Let us choose the origin as our reference point and integrate. We name this equation 1. Integrate 1 from the origin to the point x, y, z. So in this integral, our point A is origin and point B is general point x, y, z. Now path is our choice. Now what we do, we choose for the path of integration, we choose the broken line from 0, 0, 0, which is origin, to x, 0, 0, to x, y, 0, to x, y, z. So try to understand the path of integration. We choose the broken line from 0, 0, 0 to x, 0, 0, to xy 0 to xy z. So first we move from, let me use another color. First we move from 0, 0, 0 to this. Then we move from x, 0, 0 to xy 0. Then from xy0 to xyz. Let us do the calculation. Now from 0, 0, 0 to x 0, 0, we have y equal to z equal to 0, and that means dy and dz is 0. So the integral is 0 along this part of the path. Understand it? I'm saying from 0, 0, 0 to x 0, 0, we have, since we are moving from along x-axis, y and z both are 0, therefore dy dz is 0. So the integral is 0 along this part of the path. You can check. Y is 0, z is 0. So when y is 0, this term vanishes. Dy is 0, dz is 0. All the three terms in the integral become 0. So the integral is 0. Then we have to move from x 0, 0 to xy 0. Second part of the path is x 0, 0 to xy 0. Now, along this path we have x equal to constant, because x is not changing. Z is 0. That means when x is constant, dx is 0 and dz is 0. Understand it? X is constant, dx is 0, z is 0, dz is 0. So what happens to this integral? So the integral is x square dy 0 to y. X square dy 0 to y. Check this. Dz is 0, so third term is 0. Dx is 0, first term is 0. Only second term remains, which is x square dy. And limit of integration is we are moving along y-axis from 0 to y. From 0, this is y of initial point, y of final point is y. So evaluate this integral. It is x square integral dy 0 to y, which is just x square y. Integral x square dy 0 to y is x square times 0 to y dy, which is x square y. So this is the value of the integral for second part of the path. Let me write it. This is for first part. This is for second part. We have third part. Third part of the path is xy0 to xyz. Now for third part, of the path that is from xy0 to xyz. We have x is constant, going from x to x, x is constant, y is also constant, y is constant. That means dx and dy both are 0. X is constant, y is constant. That means dx and dy both are 0. So the integral is, what is the integral? We have dx and dy 0. Dx is 0, first term goes, dy is 0, second term goes, only third term remains. That is integral, third term is negative. So the integral remains negative, 0 to z. Limit of integration is on z. And along z, we move from 0 to z. Inside the integral, we have 3x z square plus 1 dz. 0 to z, 3x z square plus 1 dz. You can check it. Third term is this one, minus 3x z square plus 1 dz. Limit of integration is from 0 to z. So let us evaluate this. When you evaluate it, you can check it. It is minus x z cube minus z. Minus x z cube minus x z cube minus z. So adding these three results, adding these three results, which three results? For first part of the path, the value of the integral is 0. This thing. For second part, it is x square y. For third part, it is x minus xz cube minus z. So when we add them, we get the scalar w. So w is x square y minus xz cube minus z. Let me encircle it. So w is x square y minus xz cube minus z. Now phi, the corresponding scalar potential or potential energy, that phi is minus times w. So when we multiply w by minus, we get minus x square y plus xz cube plus z. Minus x square y plus xz cube plus z. It is just negative times w. This term becomes negative, this positive, this positive. So we get phi minus x square y plus xz cube plus z. So this completes our solution. Let me summarize it. The question was like this: show that this force field is conservative and find a scalar potential phi such that F is minus del phi. So what we did, we first calculated the curl of F. It turned out to be 0, which establishes that F is conservative field. So I gave you homework to check this determinant, whether it is 0 or not. It is 0, you check it. Then we calculated work, and we specified the path, simple path for our convenience, because f is conservative, so work done is independent of the path taken between the initial and final point. Our initial point was origin and final point was general point xyz. Then we took a broken path from 0, 0, 0 to x, 0, 0 to xy, 0, then to xyz. We calculated for 3 parts of the path this integral, then added those 3 results. We got our work. Then phi is negative times w, and we solved for the corresponding scalar potential. So this is all for today. Go through all the video lectures. Don't waste your time, and don't forget to like, share, and subscribe my channel. Thank you. God bless you. Assalamu alaikum.